For the given circuit, I need to find the Thevenin circuit for terminal A and B. So I need to find the open circuit voltage at this terminal and the resistance seen from the value of resistance seen from this terminal. So in order to find, let's find the open circuit voltage first. We can see that there are two independent voltages, one voltage source and one independent current source. Now what I will prefer in this circuit to do is I will apply principle of superposition. So I will handle one source at a time. So first I will do for the voltage source, that means I will make the current source inactive. So the current source will be open, that branch will be like that. So here this is there, this is there, and the voltage source is there. So that's 24 volts, 10 ohms, 10 ohms, 5 ohms, and here is 16 ohms, and this is our terminal A, B. Now I want to find the open circuit voltage here, VOC or VAB, whatever. VAB is VOC. So with this arrangement, this one is open here, the current source is gone, so there is no current through that branch, and this is terminal AB is open, so no current will flow through 16 ohms resistance as well. So current will be confined only here. So our VOC will be actually just the drop across 5 ohms resistance. So we basically have 124 volts voltage source and series resistance 10 ohms, 10 ohms and 5 ohms. That's what we have. So we can apply voltage divider rule. So VOC, which is basically the voltage drop across the 5 ohms resistance, will be 24 here, and sum of the divided by sum of the three resistances and multiplied by the resistance across which we are finding the voltage. So basically applying voltage divider rule. So we have 24 here and 25 here and 5 here. So what I will write, I will leave it as a fraction, 24 over 24 over 5 volts. That's the open circuit voltage for the voltage source. When we consider the voltage source only, that's our VOC. Now we have to we can call it VOC1 because this is one part of the open circuit voltage as we are applying principle of superposition. Now we will consider the current source and we will make the voltage source inactive. So our circuit now will become, the current source is present, so that's there, and we have this one, we have this resistance, the terminals of the voltage terminal across the voltage source will be shorted. So that's there like that, and this is 16 ohms and that's there. So 16 ohms here, 5 ohms here, 10 ohms here, 10 ohms here, and the current source is 3 amps. Now all we need in this case is we need the open circuit voltage, that is VOC here. So we need basically the drop across 16 ohms and 5 ohms. So we just need those two. So looking at this circuit, the 3 amps current will go in this direction, then it will encounter, these terminals are open, so this will encounter two parallel paths. One is the 10 ohms resistance path, so this one, and other parallel path is this one. And then finally the current through the 16 ohm resistance, this resistance will be again 3 amps. Because the same current has to come back and it will return in this way. So that's the current flow in this circuit. So when we look at this one, we know the current through 16 ohms resistance is 3 amps and the voltage drop will be in that direction. So V16 will be the voltage drop across the 16 ohms resistance. I can write V16 will be 16 times 3, that is 48 volts. That we know, we can just write from observation. The other voltage, other thing we need is the voltage drop across the 5 ohms resistance. Now what is the current through that? We, as I said earlier, the current will be divided at this point. The current will be divided between two parallel paths. One is this one and one is this one. So if I apply current divider rule to find the current through the 5 ohms resistance, that will be 3 is the total current, and there are two parallel paths. One parallel path contains a resistance of 10 ohms, the other path contains 10 plus 5, and we are interested in current through the 10 plus 5 path, though, because that's the current here. So the total resistance in this path is 10 plus 5, that's 15. So we will multiply by the other resistance, which is 10, with this one, the path or the resistance of the other parallel path. So like that. So it's 3 times 10 here, and here this is 25. So basically we have 2 here and we have 5 here. So 6 over 5 amps is the current through the 5 ohms resistance. So the voltage drop through the 5 ohms resistance will be 6 over 5, the current times the resistance, which is 6 volts. Now this current is also going in that direction, so the voltage drop is like that. So our VOC in this case is becoming the voltage drop, this one plus this one. So our VOC will be negative, because plus minus is, it has to be to compensate, it has to be minus plus in that direction. So our VOC, which is the open circuit voltage, will be minus 6, and so minus 6 plus 48, so that's minus 54 volts. That is our voltage drop because of the current source. So VOC in total will be, this is the voltage drop due to the current source, and the other one, the voltage drop due to the voltage source, was 24 over 5. So that was 24 over 5, which is basically 4.8 volts. So subtracting, we are getting minus 49.2 volts. That's the Thevenin's voltage for the circuit. So V Thevenin's is minus 49.2 volts. So different polarity. So when we draw the Thevenin circuit, it becomes like that. That's all it is. And now we need to find the resistance. So this is the circuit for AB, and the polarity will be like that. So 49.2, that is what the negative sign means. And we need to find the resistance as seen from here in the original circuit, as seen from here, provided that the current the sources are inactive. That means the current source open, source or sources, and voltage source or sources short circuited. So with that, we have this circuit arrangement. The current source is open there, we have this one here, and we have 16 ohms there, like that, and we need to find the resistance as seen from here. And this one is there, the voltage source here is short circuited, 10 ohms, 10 ohms, 5 ohms, and 16 ohms. Now what we have, the resistance, let's call it R Thevenin. This is R Thevenin. So that will be 16 ohms plus, that's in series with parallel of 10 plus 10, these two are coming in series, so 20 parallel 5 ohms. These two are parallel paths, so 20 parallel 5 plus 16 is the total resistance. So this is the series resistance, and then this is one resistance here, and the other series resistance is the parallel combination of 10 and 20 and 5. So 16 here. I hope it's obvious. I have done previously some equivalent resistance problems. So this is 20 times 5 over 20 plus 5, which is 25. So that's basically 4. So 16 plus 4, that's 20 ohms. So that's our R Thevenin for the circuit. So this is 4 ohms. So this is the Thevenin's circuit, Thevenin's equivalent circuit for the given, for those two terminals from the given circuit, from terminal A and B.